Okay, so in the previous video, we have shown you that the P implies Q is logically equivalent with not P or Q. And we have shown this using a truth table. Okay, so we have the not P taking the negation of P and the not P or Q resulting to true, false, true, true, and the implication of P and Q is true, false, true, true, which these two columns or these two statements having similar na truth values and therefore logically equivalent. So we will use this rule to establish the rules, our conditional statements. So we have already established this one and we have solved that using a truth table. Okay, and then there are also other conditional statements or logical equivalences involving conditional statements. So is this familiar to you? So P implies Q is logically equivalent to not Q implies not P. So this is the contra positive. Okay, contra positive. Okay, we have the P implies Q is logically equivalent to not Q implies not P. What else? So it is also this is also logically equivalent. You have the P or Q and not P implies Q. So we can actually use the laws that we have established in order to prove this statement. Suppose let's work on the not P implies Q. Okay, so we have the not of not P or Q. So the not of not P is P or Q. Okay, so which shows that these statements are indeed logically equivalent. So let's try to get back to this and try to prove this. So we have the not P or Q. So we can say that Q or not P. Okay, so we can rewrite Q as not of not Q or not P. Okay, and this using the implication which has a value of not P or Q, we can then express this into this form. Okay, so we have the not of Q implies not P. Okay, so you can see that you have also the not and the or, okay, which makes it valid. Now, let us try to prove this statement. On the other hand, the P and Q is logically equivalent to not of P implies not Q. Okay, so we have not of, first let us simplify the implication. So we have the not P or not Q. Okay, so we will distribute the negation operator to the factors. So we have the not of not P and so this or will become and. Now we have the not of not Q. Okay, so simplifying this double negation, the not of not P is equivalent to P or Q. Okay, so which shows that these statements are indeed logically equivalent. Now, let us move on to this. The not of P implies Q is logically equivalent to P and not of Q. So we have the not of, first, simplify natin yung implication or P implies Q. So this will be not P or Q. Okay, so now let us distribute the negation operator using De Morgan's. So we have the not of not P, and this will become and, okay, and the not of Q. So this will result to P using the double negation. The not of not P is P, and not Q, which shows that indeed they are logically equivalent. Okay, so